Okay, so this is a hyper subtle implementation detail of the Linux kernel that probably no one's going to care about, but I think is funny and kind of interesting, so I'll try to explain it. Basically, the core page fault handler of the kernel does not do validation on memory accesses. So if a write is being done to unwritable memory, there's going to be a lower level page fault handler in the architecture specific code that checks that. And the core page fault handler is not is going to assume that check already happened and not going to do that check. And there's a very specific reason why it's designed this way. And it's to support stuff like /proc mem, where you can do kind of like sketchy writes to unwritable memory. And here's why. And so let's say we're doing a write through /proc mem into the code of libc in our process, which is in a shared unwritable mapping. So the kernel code behind /proc mem is going to, it can't directly write to that page, because otherwise then that change would be visible in every process on the system. And so first it's going to need to do a copy on write and get a private copy of that page. The functionality for doing all the copy on write stuff in the kernel is in the page fault handler. And so in order to reuse the page fault handler for this, it's going to basically trigger like a fake page fault. And that's what we see here in this fault in page function. It's just going to call the page fault handler mmFault to kind of emulate a page fault. And what we're going to see is that the core page fault handler does something kind of interesting. So like I said, it omits or it doesn't validate memory accesses. And so it assumes that happened earlier. And we'll see, and this manifests itself in a pretty interesting way right here. Right here. It manifests itself in the form of an omission of a check. And so here is where we check, are we doing a write to an unwritable page table entry? And then it does the copy on write. There really should be a third check here. If we're doing a write to an unwritable page table entry, that actually corresponds to a writable page, a writable VMA. There should really be that third check. But that's only if the page fault handler is doing access validation. But instead, we see this omission. That check if the page is actually writable is omitted, because otherwise, if it was there, then the /proc kernel code would not be able to reuse the cow infrastructure in the page fault handler, because then that check would fail. And so it's kind of like the kernel's turning a blind eye a little bit here. It's basically just kind of giving a pass to this kind of sketchy behavior, because it knows that certain parts of the kernel need to do stuff that's not really allowed 99% of the time. So that's one hypersubtle thing. There's this check omitted, and the core page fault handler doesn't do validation. There's another subtle thing that I'll also touch on. In the cow function for handling shared pages where we actually need to do a copy, there's something pretty interesting. So here's where we allocate the new page, and then we copy the old contents into the new page. So here's where like the copy of libc's code would occur. And then finally we need to map that into the process. And we do that right here with these page table entry lines. And specifically, it's interesting that this maybe make write function is called when initializing this new child page table entry, because under 99% of the time, we would expect to be setting the right bit on the new child page table entry, because we're doing a copy on write. So that page is probably almost always going to be like writable. But in fact, no. I mean, in this case with /proc writes, we can write to unwritable memory, and so the kernel cannot unconditionally set the right bit here. And it actually needs to do this maybe make write, which is only, the maybe part is only going to be relevant in, again, this 1% of the time where we're using, /proc whatever to do kind of sketchy writes to unwritable memory. But it still needs to include that maybe make write, which again does this conditionally sets the PTE write bit based off of the parent VMA, which is that libc code. And so this is just two like really hyper subtle implementation details of the page fault handling infrastructure that I thought were pretty interesting, and just wanted to share.